Chapter 8 Basic Concepts of Chemical Bonding. Calcium carbonate is one of the most interesting and versatile compounds on the planet. It accounts for roughly 4% of the Earth's crust and is a major component of rocks such as limestone and marble. The White Cliffs of Dover in southeastern England are one of the most famous natural formations of calcium carbonate. The cliffs consist almost entirely of a porous form of limestone called chalk. Unlike most inorganic substances, calcium carbonate is widely used by living organisms and is found in objects such as seashells, coral, eggshells, and pearls. Calcium carbonate plays a role in the complex chemistry associated with the greenhouse effect because it is formed in the oceans through the reaction between calcium ions and dissolved carbon dioxide. When limestone is heated to elevated temperatures, calcium carbonate decomposes into solid calcium oxide, an important industrial chemical called quicklime, and gaseous carbon dioxide. Calcium carbonate undergoes the reactions that it does because the atoms in the carbonate are held together by a combination of two different types of bonds. The carbon and the oxygen atoms that make up the carbonate ion share valence electrons, resulting in the formation of covalent bonds. The oppositely charged carbon and carbonate ions are held together by electrostatic attractions, which are called ionic bonds. The properties of the substances are determined in large part by the chemical bonds that hold their atoms together. What determines the type of bonding in each substance? How do the characteristics of these bonds give rise to different physical and chemical properties? The keys to answering the first question are found in the electronic structure of the atoms involved, which we discussed in Chapters 6 and 7. In this chapter and the next, we'll examine the relationship between the electronic structures of atoms and the chemical bonds they form. We'll also see how the properties of ionic and covalent substances arrive from the distributions of electronic charge within atoms, ions, and molecules.